Hello guys, in today's grade 12 physical sciences vertical projectile motion exam clinic, we're looking at a question paper from Gauteng Province. This is their physical sciences paper 1 of June 2025. As you can see, this is 16 marks, so we must spend at most 16 minutes. So let us see what this question was about. I'm going to zoom in slightly. Okay, this is better. Perfect. So let's see. Question 4, we start now. So we have, let's see, they say a hot air balloon moves upwards at a constant velocity when a block B is dropped from the side of the balloon and falls to the ground. The balloon is 15 meters above the ground when the object is dropped. So I want to say this velocity of, let's say, I'm going to call it object, okay? So I'm going to say object relative to air, not to air, but to the balloon, rather. Relative to the balloon, okay? Relative to the balloon is 0 because it's dropped. And velocity of the balloon, it's not yet given. So let's see. They said the height of the balloon. So the height of the balloon is 50 meters, all right? The graphs, how many graphs are there? Okay, the graph below shows the motion of the balloon and the block B, all right? Of the balloon and the block B, all right, cool. The graphs are not drawn to scale. Oh, I do see them, are not drawn to scale. Ignore all effects of resistance. Use upwards as positive in all calculations. This is important. Now, which one, the balloon or block, is in free fall? Remember, the object that is in free fall will be the one that experiences gravitational force only. So when you look at hot air balloon, its velocity is constant. That is not free fall. So we will say it is block B. All right? It is block B. And then they say give a reason for your answer. Right? When they say give a reason for your answer, what do you say? Look at the curve here. Look at the curve here. All right. So this velocity is changing uniformly. All right. The velocity is changing uniformly. That's one reason you can put, is changing uniformly. Or if you don't want to say the velocity is changing uniformly, you say for vertical projectile motion problems, acceleration is 9.8, right? Or for vertical projectile motion, all objects are in free fall, okay? All objects are in free fall. There are many reasons that you can put forward, okay? There are many reasons that you can put forward. Another reason would be the gradient of the block B graph is gravitational acceleration. It can also be that, okay? Cool. 4.2, let's proceed. 4.2, it says, using only equations of motion, calculate the following. The time t1. I want you to understand this. At t1, and by the way, guys, if you are using a mobile device, please rotate your screen so you maximize your view. So 4.2.1, using equations of motion, you have final velocity here, which is 0. You have initial velocity, which is 5, and you're looking for the time. Remember, vertical projectile motion calculations are positive. So upwards as positive. What am I saying? Vertical projectile motion calculations are vector calculations. So you must state a direction you want to be positive. All right. So here we will use the formula V sub F equals V sub I plus A delta T. At T1, that is maximum height. So we'll say velocity there is 0 initially. As you can see, it's positive, so it's going to be positive. Acceleration is a downward motion, so it's going to be negative 9.8. We do not know what the time is, right? Perfect. So 9.8 delta t equals 5. 5 divided by 9.8 will be 0.51 seconds, isn't it? 0.51 seconds. Remember, you leave your final answers correct to 2 decimal places. Let's go on. 4.2.2. They say, using only equations of motion, calculate the velocity v of block B. Velocity v of block B. So what is this velocity here? Sorry. This velocity here is the velocity with which block B strikes the ground. So once again, upwards is positive. Remember, they said for all calculations in this question, always use upwards as positive. Okay? Then we have initial velocity. Do we have it? Yes, it's 5. Final velocity we do not have. It's called v. We have the height. So we will say final velocity squared equals initial velocity squared plus 2a displacement. Now, what is the final velocity? It's termed v. Initial velocity, it's positive 5, so it's 5 squared. Acceleration is negative 9.8. The displacement here, because the 50 is the height when the object was dropped, we can say this will be negative 50. Okay, why do we say that? I want to show you now. I said this is displacement, right? So it'll be moving like this. If this position here was 50 meters, if this position here was 50 meters, agree with me that when we talk displacement, going up, returning to that initial position, we can say displacement is 0. Right? Now moving from this position here, going down, the displacement is 15 meters. Now because it's a downward motion, hence I'm putting the 50. This is the height at which the object was released. So let's see. This is 1005, that's v squared. So v will be 31.70 meters per second. This is the velocity with which the object strikes the ground. It has to be negative because it's a downward motion. So we'll just say it's downwards. Okay. Because the question did not say magnitude, but rather it said calculate velocity of block B. Okay, moving on. Now we must find time t. This is the time it takes the object to hit the ground, right? So we have two ways of, we can use either equation we like as long as there's one that uses time, okay? So I'm going to use, once again, upwards as positive, okay? You have final velocity terms. You can find time. So we can try with this one. V sub f equals V sub I plus A delta t. Then what is V sub f? It is 31.70 downwards. So it should be negative, right? Initial velocity was 5 meters per second upwards. Acceleration is 9.8 meters per square second downwards. So it has to be negative. and delta t. Let's see now. This then becomes, if you like, 9.8 delta t becomes 36.70. All right, let's see now. 36.70 divided by 9.8 will be delta t equals 3.74 seconds. Okay, it becomes 3.74 seconds. And the reason you're getting 0.74 seconds is because you used the v that you calculated there, right? If you had used that v the way it was previously, you recall previously this v, square root of 105, 1005 rather, it was going to be, for example, let me show you, it was going to be negative 31.70173 equals 5 minus 9.8 delta t. This was going to be 9.8 delta t equals 36.70173. Then let's try it. What do you get? Do you see? Now you get delta t equals 3.75 seconds, right? So it doesn't matter, right? And again, you can use a second equation. You can use this one here. Let me show you. You can also use this one here. Delta y equals vi plus vf all over 2 all multiplied by delta t. You will still get the same answer. Okay, but let's move on. So let's see. Moving on. Oh, 4.3. We are almost done. 4.3. Cool. 4.3. We have, they say, sketch a position time graph of block B from the moment it is dropped until it reaches the ground. Use the ground as a reference. So once again, if you choose upwards as positive, okay, once again, if you choose upwards as positive, acceleration is negative, so the graph will be frowning. Alright, the graph will be frowning. The key word here is that you must use the ground as a reference. So I will be doing this, that's fine. And then this is the ground, this is the time in seconds, then this is position in meters. Initially, the object was 15 meters above the ground, and then it goes up in the air and boom, going downwards. Oh, this is not a good quadratic. This is better. Right, so this is 50 meters. Let's see. You must clearly indicate the following values on the graph. The initial height, cool. The time at maximum height, the time, where was it? It's 3.7, no. What is the 3.75? Okay, it's the one to strike the ground. That one was 0.51 seconds. 0.51 seconds. And the 3.74 was the one it took to hit the ground, right? And the time when the block B reaches the ground. So this is it. All right, this is it. Okay. And this is how you answer vertical projectile motion questions. Do you see? We're able to finish way before 16th minute. So that's the way to go. Bye-bye.